And also, Justin Bieber is a cuber. I don't know if you've seen this before. So regardless of your opinions about Justin Bieber, if you know him or if you have never heard of him, he has featured cubing somewhat prominently in a couple of his interviews. So this is the kind of thing where cubing is starting to come back now. It used to be very much on the fringes. You didn't really see it in the media that much, but you're starting to see this more and more now. So back to the cube itself. Again, the main focus of today, we're leading up to, I do want to talk about the blindfolded stuff and how the memorization works. But before we can do that, we have to know what is a Rubik's Cube. Physically, how does this work? If you were to break one open, what does it look like on the inside? And this is a cube that is, for the most part, almost completely disassembled. The center pieces, so if you're looking at a side, the piece that's in the very middle, is what we call the center core, and that's attached to this core here. So that's the yellow center piece, which would be the same as the middle one on my yellow side on this cube. You also have corner pieces, which have 3 stickers on them. So if I have a cube and I cover up all of the stickers around it, you can see that a corner has 3 stickers. And then there are also edge pieces which have 2 stickers. So I have the orange-yellow edge here. And the edge stickers are ones like this piece here. So you can tell that the pieces are shaped somewhat differently, and they have these protruding parts. Once all the cubes are put together and you click the last piece into place, you actually hear a very loud pop. And what that is that's all the cubes interlocking and snapping themselves together. So the reason a cube holds itself together pretty well, and it doesn't fall apart, even though you can see it's made of a number of pieces, is once the last one's put into place, they all lock themselves and hold themselves in place, yet are still freely able to turn. It's a really, really ingenious design. Yes?
If you take it apart and try and put that together, is it possible to put it together in a way in which it can't be solved? Or?
Yes, actually, and that's coming up very shortly. I'm also going to talk about how many different ways can you scramble a cube. And how many possible positions are there? And the number is actually pretty surprising. So the cube is made up of 8 corners, which we can see on a solved one. We've got the 8 ones on the outside. And if you look in the middles and count all the edges, which are these pieces, you've got 12 of them. Okay. That is how many possible scrambles there are to a Rubik's Cube. But notice I put the word legal scramble. So the idea is if you were to disassemble a cube and put it back together, not all of the ways you can assemble it are possible. It turns out if you break apart your cube and put it back together, still scrambled, there's only a 1/12th chance that you can still solve it just by turning the sides. So the number of ways you can just reassemble a cube is actually 12 times this number. And this is 43 quintillion, which is a very, very difficult number to grasp. Yes?
You're saying that number is the number that can be solved?
Yes.
So you put together, okay.
Exactly, which was actually kind of surprising. Now, for those of you who, like if you studied math or you're interested in math, part of the reason that number is so incredibly huge is the 8 corners only stay in the positions where the corners are. You can never replace a corner piece and an edge piece. You can't swap those two. Corners only stay in the positions where corners stay. We call it the corner orbit. Same thing for edges. The way to place the corners are, there are 8 choices for where to put the first corner, times 7 choices for where to put the second corner. So you're doing 8 times 7 times 6 times 5 all the way down. And you do the same for the edges. 12 possible ways to place the first edge, times 11 ways to place the second edge, times 10 times 9, all the way down. And those two numbers are multiplied together. So that's just giving you an idea of why this number is so incredibly huge. To give you a visual example, some people have done some calculations for this. If it was possible to carpet the Earth in Rubik's Cubes, so the surface of the ocean, every piece of land, all the way up the mountains, everything. If you could carpet the Earth with Rubik's Cubes, and you had 1 cube for every different possible scrambled state, you could cover the Earth over 400 times. So you could cover 400 Earths with this number of cubes, and actually a bit more. So it's absolutely enormous. It's hard to picture that number.
No wonder I couldn't do it.
So okay, next up, I do want to show you some demo solves, because if we're going to be talking about Rubik's Cube, I want to show you, well, what is this whole speed cubing thing? So hang on real quick. I've got my speed cube here. And let me see.
My speed cube, is it like specially lubricated to move fast?
It is. Yes, so speed cubes are actually specially prepared. This one is just my example cube. I use this one for demos. This cube is one that I got online. Now, there are different brand Rubik's Cubes. The comparison is it's kind of like you can buy a different make and model car. There are a number of different companies now, some not necessarily always operating perfectly legally, so there are sometimes lawsuits going around from Seven Towns, who is the owner of the official Rubik's Cube. But essentially, there are speed cubes that are purpose-built for turning very quickly. So these cubes are much, much easier to turn. They're much lighter. The cube itself is not quite as heavy as one you would get in the store. The pieces are usually hollowed out, and most of the plastic is shaved off them because you don't want the weight there while you're turning it. You want it to be very nimble and very light. So if I can have somebody scramble this up, I'm going to go ahead and just do a quick speed solve. So, do you mind? And so, one of the interesting things, I'm going to go back to how many possible scrambled states there are on the cube, that huge number we saw. They recently found what's called the diameter of the cube group, which basically is kind of a math way to say that the furthest possible you can be away from the solved state is the diameter, in a sense. It's any two positions on the Rubik's Cube scramble. How many turns does it take to go from one to the other? And what is that maximum number? So it turns out 20 turns is the diameter of the Rubik's Cube group. This was proven recently. There was a very long unsolved problem. What that means is any scrambled state of the cube is at most 20 turns away from the solved state. So when you're scrambling a cube, if you scramble more than 20 turns, you're actually not really doing anything more to it per se. You're just putting it into a different scrambled state. But you can never go more than 20 turns away. There are no positions that are further away from solved than 20. So what I'm going to do is I'm actually going to do, the first one I want to do is a speed solve. So essentially, if you'll give me a quick countdown, I'm just going to go right into it. I'm just going to solve it as quick as I can. So go ahead. And exactly. If you want to time, no, this is how I'm used to doing it. So. And just give me a 3, 2, 1, start.
One, start.
Who's timing? Just so I know.
3, 2, 1, start.
Okay. So I'll try to hold this up so it's a bit easier to see. Okay, and at that point I'm most of the way done. And that finishes it. So
21 seconds.
21? Okay, so that was, it sounds like that was 21 seconds. So.
21
Did you do more than
seconds.
20 moves there?
Yes, I actually did probably closer to 60.
You were going for time rather than for number of moves.
Exactly, and there is an event that is one of my personal favorites, but I'm not quite as good as some of the experts here. There's an event called Fewest Moves in tournaments where you are given a scramble and you're given 1 hour to come up with the shortest possible solution. And there's no, you don't have to execute it. You don't actually have to do it on the cube. You just write it down. And the world record is currently 22 turns. And it's held by 2 different people, actually. So interestingly enough, it's held by a guy named Jimmy Cole, who it was the first person to set 22 moves. And then it was later also tied by a man named Hus Schultz, who was the #2 guy in the 1982 championships. He got 2nd place for the speed solve event. So he's kind of an all-arounder. He's been around for years. A speed solve generally takes between 50 and 60 turns because the idea is I want to have prepared patterns. Speed solving is very much pattern recognition. I see a sequence of turns, I do it. I don't have to think about what turns to do because I've already beforehand practiced based on this pattern. I already know which turns will solve that. I don't really have to plan ahead for it. So, yes?
So it's not necessarily obvious to be able to just look at it and say how, but if they give you an hour to do it, it is possible just by looking at it to determine how many moves it should take.
Yes, and you are allowed to turn it, actually. I definitely should have clarified. When you're doing the Fewest Moves event, you can use actually up to 3 different cubes and try out different sequences, but your solution or your entry is what you write down. But you're definitely allowed to spin it and figure out, does this work? Can I use this sequence? Is this one better? So there's a different event that people do where they don't even write the turns down, which is kind of related to the blindfold stuff. And that's actually my next demo. So the next demo I'm going to do is another solve, except this time I'm not going to look at it while I'm solving it. So I need a volunteer scrambler. So I'll go to the other side, I guess. So,
What's the current world record for speed?
For speed solving? The current record for speed solving is 5.66 seconds. And that's held by Felix Zemdegs from Australia. So he's essentially the Michael Jordan of speed cubing, or, back when he was huge. So, yes.
Doesn't it depend how much somebody scrambles a cube? Or in competitions, do they have so many turns to scramble it enough or whatever?
They actually, there's a computer generator that generates a random state of the Rubik's Cube. So it actually just randomly pulls up one of the possible scrambled states and then gives a printout of how to set that up. Some solutions are easier than others, though, yes. So sometimes when you're doing